Hello, we are group 2, and as a group we consist of Johannes, Veronique, Konstantinos, Janan, Mohsen, Noha, Stefan, Clement, and myself. As well as group 1, we will be comparing the digital and traditional pharma business models, and we will be focusing on freedom to operate, system boundaries, and patent types. So let's start.
Yes, let's start with the system boundaries of traditional pharma versus digital pharma. In the traditional pharma, there was a clear and simple product structure. We had, for example, a drug, which was a technology, which was produced by technology with a certain technology, and this it became a product. And we had one patent subject, so one business model was enough for clear, defined system boundaries. But with digital pharma, we have now a little bit complex system. I will start from the inside to the outside. We have, so to say, a basic layer with sensors, with control of parameters, pumps, and also here the artificial pancreas, which provide an interface and information to the management system, which consists of the profiles of the patent, the drug, the meal, the activity. Further, of course, also important is the historical data, simulation models, optimization models, and an alert model, of course. This management system, again, has to have an interface to the outside for the patient, for the physician, for the insurance, and also for a complementary product platform, and a complementary service platform. So you see, this is a highly complex product structure. The business model largely determines required technologies and system components. So it's undetermined and a fuzzy system. So this is an undetermined and fuzzy system boundary. Thank you.
Thank you, Johannes. So now let's talk about patent types and their assignment to our two business model. So what was the previous slide? Could you go to the previous slide? Thank you. We are going to talk about patent types. So first, what is a patent type? A patent type is something which describes a class of established problem solution combination related to a business model or part of this business model. So if we look here at the traditional pharma business model, we have one patent type, which is number 2. And here, this patent type is related to a super fast-acting insulin composition, and it's for the whole business model. On the contrary, for the digital pharma business model, we have not one but 3 patent type. So if we start with the patent type 3, here it's something which allows to optimize implantable glucose sensor, and this patent type is linked to just a part of the core system, which is the sensor. Then if we talk about patent type 1, here we have a system and a method for controlling and monitoring the diabetes management system. It's why it's here linked to the whole core system. At the same time, the sensor, the artificial pancreas, the parameter control, and also the pump control. And let's finish with the patent type number 4, which is related to the whole data management system. And so here it's another time is linked to the whole management system. At the same time, the patient profile, the drug profile, the meal profile, and so on. So now we can move to the next question.
So obviously this assignment of multiple different subject matter for the same product have direct implications in the way the freedom to operate is performed, the complexity of the freedom to operate, which of course associates with the cost to perform it, and the number of players in the particular areas associated with the types of patents. So for example, for traditional pharma, as Veronique explained, in patent type 2, companies traditionally were filing applications for a molecule, for example, insulin compositions. And then we can see that, for example, the international patent classification codes relates to medical or dental technology, and the top applicants are traditional pharma companies. What is also interesting to see is that the number of applications in this narrow field is decreasing. On the other hand, when we pass to the digital pharma space, and then on top of patent type 2, we also have patent type 3, 1, and 4. I just read it from left to right. Then we can see that the complexity increases. For example, the number of IPC codes changes. So now we don't only have medical or dental technology, but we start to see some new codes, for example, sensor technology, and then applicants like Siemens and Dexcom and Medtronic, which are more companies related to the electronic part of healthcare applications, are into play, and the number of applications now instead is increasing. Patent type 1. For example, when we want to define closed loops, we also see further companies that traditionally are active in the electronic space, like Philips, come into play. And then it gets completely different when we talk about patent type 4, where the IPC codes now include, do not include at all medical and dental technology, but we are talking about computers, data management, data representation, acquisition of data, presentation of data, transmission of data, and so on. The top applicants are traditional, so to speak, IT companies who in principle have nothing to do with healthcare, while the number of patent applications is at least a factor of 2 more than in the previous fields, and is constantly increasing. So the more we move towards a digital system components, the classification becomes even more fuzzy and more complicated, and the number of applications and relevant owners is increasing exponentially. So next.
Thanks, Constantino. Following our introduce a traditional FTO for the pharma business, this will be like this. The step 1 is assemble the research item into contributors and elements, and then the second is select the regional coverage of the research, that is the regions or countries the market want to seek a market. The third step is select a special database, because each database has its own unique strengths. So choose a suitable and special database for pharma helps a lot. And the fourth step is specify the application-oriented classification symbols. That this part has been already presented by Constantino in detail. Then follow is define the keywords. These keywords could be found in either contributors or elements like key pharmaceutical ingredients, ratios, or unique pharmaceutical process. And then we could create search strings using a different logic to combine words in order to find more relevant documents. The 7 steps is search we could carry out different search strategies by using different search strings and the IPC. And during the search process, we could modify the search strings as well as the IPC dynamically according to the search results in middle, and in order to cover search range as far as possible. The last one is to evaluate the search results. This analyze the search results to determine whether the product we want to sell would infringe someone's prior art locally, or whether there's a risk of infringement. This could give advice on IP for the further marketing plans. Next, my colleague will present the FTO process for the digital pharma business and the changes comparing with the traditional one.
Thank you so much, Yanan. For the digital pharma, we have similar process step and additional process step from a traditional one. At the first, we must disassemble the research item into attributes and elements, and then weight attributes and elements, and go to select critical attribute and elements, and then select regional coverage of the search to specify application and function oriented classification symbols. And after that, must define the keywords to create a search string and then search for evaluate search result to match search results with characteristic structure. And Nora, the floor is yours.
Would you skip to the next slide, please? The last task of our case study part was the timeline of the FTO process and the differences between the traditional pharma and the digital pharma, mainly in the case of the development part. In the traditional pharma, there is everything before the market launch. You have the product, the service, and the business model development, then the FTO and the market launch. That means that the products that were once introduced to a market are unchangeable. This kind of FTO analysis seems to be as a snapshot. This is the difference in the digital pharma. In this case, the FTO analysis performed as a continuous support process. As you can see in the top, there is a product, service, and business model development also on the left side, but then there's a market launch, and there's an ongoing development. There are still improvements, and the digital business models are being continuously developed, expanded, or modified in case what is needed. There's a co-creation between the product management, the R&D department, and also the IP. And the FTO process is over the whole time. As a summary, you can say in the traditional pharma, the FTO is checked and not done twice. And in the digital pharma, the FTO is established. And now, Stefan.
And with that, we thank you and recommend to close the day.